Class, now let's turn to the mechanical approaches at our disposal for making selection decisions. I mentioned before that we will be using algorithms, but these algorithms are more like decision rules. Yeah. So to help make these decision rules more concrete for you, I'd like you to try this exercise with me. After you finish your time in UWA, do you plan to stay in Perth or move elsewhere? Maybe over east or overseas or through rural WA? I'd like you to make a list of the pros and cons of staying in Perth after you finish uni. Yeah, you can pause the video while you work on your pro and con list. Just a simple list, should take you 2 minutes. And then when you're done, you can continue. Now, you've got your list of pros and cons. How do you make a decision based on your list? The easiest approach, class, is to use the pick the best heuristic. So among your pros and cons, you would choose the strongest pro and the strongest con only. Yeah, and you would pit the strongest pro against the strongest con. And then based on which of those is stronger, that's the choice you make. So if the strongest pro of staying in Perth is more important to you than the strongest con, then you stay in Perth. I like to call this the Charles Darwin approach, because this is how Darwin decided whether or not to marry his cousin. He made a list of pros and cons of marrying his cousin and then simplified his decision process by focusing on only the biggest pro of marrying her versus the biggest con of marrying her. And he did indeed decide to marry his cousin. The pick the best heuristic is a good option for when you need to make a quick decision straight away. But that's not the only approach at your disposal, class. You can also choose to count your pros and cons. Yeah, so add them up. Do you have more pros or do you have more cons? If you have more pros, you go with the pros and stay in Perth. If you have more cons, then you choose to leave. This is called an unweighted approach, class. It treats each of your pros as equal to each other, equally important, and it treats all of your pros and all of your cons as equally important to one another. Yeah, so the decision is made simply based on quantity. Count the pros, count the cons, make your call that way. Yeah. Now, this of course doesn't maximize all the information that's relevant, because not all pros and cons are equal. Yeah, you can decide how important each pro and each con is, and then weight them accordingly. Yeah, so you might say that one particular pro is so important it's worth double the others, so you would weight it twice. Yeah, we call this a weighted approach, class. We don't assume that all your pros are equally important to each other or equally important to all your cons, but rather we decide that some pros are more important than others, and so we give them more weight when we add them up. And lastly, you can make the choice based on deal breakers. Rather than adding up pros and cons, you start with what are the deal breakers that we absolutely cannot live with? Yeah? Is there a con that would be just utterly unbearable, or a pro of leaving Perth that would be too good to ever pass up? We call this the non-compensatory approach, where it's not that pros can compensate for each other, cons can compensate for each other, or pros can compensate for cons, but rather we say this is a deal breaker, there's no compensating for it. I will absolutely not be willing to settle for the decision if this deal breaker is present. Yeah? So these approaches line up with the selection decision rules that we will cover in today's lecture, class. So if we treat all our pros and cons equal, we are using an unweighted decision rule. If we decide that some pros or some cons are more important than others, then we use a weighted decision rule. Yeah, we apply a weight to some pros or some cons. Yeah, and both weighted and unweighted decision rules fall in the category of compensatory approaches. We say compensatory, class, because in a selection process, we basically let KSAOs compensate for each other. You can score low on one KSAO, high on another, and that's okay, because you want the best person on average. Yeah? So it's like when you're weighing pros and cons, you can let strong pros compensate for weak pros, and that's fine. Yeah. The alternative to compensatory approaches is non-compensatory approaches. This is the deal breaker approach. This is, we say here that some KSAOs are absolute deal breakers. And if these KSAOs are not present at least some baseline acceptable level, then we reject the candidate full stop. There are two kinds of non-compensatory decision rules. There is the multiple cutoff and multiple hurdle. The main difference between these two is the sequence of the process. Yeah, we'll get into this further as we go. Now, class, some of these approaches can be combined with predictive modeling. There is a statistical technique called multiple regression that will let you predict your criteria, say supervisor rated job performance, based on your selection tools, and then it will use the data to figure out what the weights should be to hire the best employee, the employee most likely to perform well, yeah, or to find the ideal cutoffs or hurdles to use in your selection process, yeah. So I'll cover all of these decision rules one by one in the next several minutes. Okay, now again, class, compensatory approaches, they let the strengths and the weaknesses of the job candidate compensate for each other. This approach does not try to pick the candidate who is the best in everything necessarily, because that candidate may not exist. Yeah, what we're trying to find is the best candidate in general, on average, across their KSAOs, accepting that every job candidate will have some strengths and some weaknesses, and that is okay. Yeah. Now, are compensatory approaches appropriate for all jobs? No, not necessarily. And we'll cover that in a bit. Yeah. But for certain jobs, it can be very effective. So let's start with unweighted decision rules. Unweighted decision rules treat all predictors as equally important. Weighted decision rules say, now you know what, some predictors, some KSAOs are more important than others and thereby given more weight. We can use predictive modeling as an adjunct for weighted compensatory approaches to let the data help us work out what the weight should be, because otherwise it can feel somewhat arbitrary to figure out this KSAO is more important than that KSAO. You can let job analysis inform that to some extent, or you can rely on multiple regression to really work out which predictors really predict performance down the track. So, class, applying these decision rules to this data set, an unweighted approach would have you add up all the numbers, yeah, and then call it a day. Yeah, so just add all these numbers, and then that's it. An unweighted rule would does not treat one KSAO or one selection tool as more important. With a weighted rule, you say, no, you know what? The integrity test is much more important. So we're going to double the value of this when we add everything up. Here is another example of a weighted approach. Here we say, you know what? The interview is the most important. We're going to give that the most weight. The job application form, we're going to give that the least weight. Okay. Now, class, working out the ideal weights for your decision rule can be challenging and can feel a bit arbitrary. Yeah. So if you have a lot of data on existing employees, say at least 100 employees in the same job, like in a very large firm, then you can look at their current job performance, which would be your criterion, let's say, and you can look at their selection scores when they underwent their recruitment process. Yeah, these would be your predictors. And then you can work out which selection tools that they underwent during the recruitment process would predict their job performance down the track. Yeah, and this will help you work out the right weights for each selection tool. This is a multiple regression approach, and it uses data to help develop an equation class that includes the ideal weight for every selection tool. So X1 might be the interview, X2 might be the assessment center, X3 might be the situational judgment test, and B1, B2, B3 are the weights for each of these selection tools respectively. Yeah, and what multiple regression does is it figures out what the best weight should be to predict performance in your 100 existing employees, and it lets you use those same weights when you're hiring future employees. Yeah, so you are selecting employees who are more likely to do well on job performance. Now, class, this approach involves a few assumptions and risks. First is it assumes that high scores on one predictor can compensate for low scores on another. Yeah, like I said, this is a compensatory approach. It assumes that any job candidate can have a mix of strengths and weaknesses, and that is okay. Yeah. Next is, it assumes that there is a linear relationship, class, between predictor scores and job performance. In other words, class, more is better. More higher score on the predictor, the better your job performance. Or it could be negative too, but either way, it's linear. Yeah. Now, the other assumption, or rather the other risk, is something called overfitting. Now, this is getting into fairly arcane statistics that I'm not going to examine you on. So I'm not going to test you on overfitting, but this is something that's important to keep in mind for when you actually put this into practice. Overfitting is a general problem with any predictive modeling where you've built your predictive model on an existing sample and it doesn't apply to future samples or to future job candidates. Yeah, so you can reduce this risk by cross-validating your predictive model. So when you run your regression, you would split your sample of existing employees into a training and test sample and see if you get the same results across both samples. Yeah, it's like I said, fairly complex, fairly mathematical. If you don't know your statistics, this is going to be fairly out there, and so it's okay. You're not going to be examined on it, but you should know this if you do end up using multiple regression, that overfitting is a big risk. And the future of this approach, which is where there is a lot of excitement, this was a fairly big topic at the Society for Industrial Organizational Psychology conference that was held online very recently. One of the big topics was, hey, how can we use machine learning to work out what the best weights should be? And well, machine learning, for those of you in the know, is basically multiple regression with bells and whistles, just a more complex version. It's not necessarily any better and actually has a higher risk of overfitting. So in this case, you're better off with plain old multiple regression. As with a lot of things, big data can be a bit overrated. This is my personal view. Others may disagree, and I may end up being proven wrong on this. So look, let's see. Let's see, class. Now, a quick refresher on multiple regression, class. It draws a line between the score on the selection tool and the score on the criterion. So here we have job candidates. Those are the dots. These are their scores on the test. On the x-axis, on the horizontal, and on the vertical we have how well they ended up performing on the job. And the line works out to this equation where 0.7 is how steep the line is, and 2.61 is the y-intercept where the line touches the y-axis. Again, this is getting fairly complex. I'm not going to examine you on this. This is just a quick refresher on how this stuff works. Now, class, this approach will give us weights that we can then use to work out which of these selection tools best predicts job performance. So here we have the regression weights. We see here that the math test has the highest weight, and the structured interview is worth only half of the math test. And look, that's what the regression model showed. That's what ultimately ended up predicting performance, and so be it. Yeah. And so what we do is we multiply the scores of every candidate. We multiply the scores by the regression weights, and then we use that to add everything up and work out the score. Now, one thing to note, class, is that the scores have different ranges. So the structured interview has a range up to 25. the filing test has a range up to 30. Of course, before you add everything up, you would adjust the scaling of every predictor so that they're on the same scaling. Yeah, the formal statistical approach used to do this is calculating the Z-score. I'm not going to cover Z-scores in this unit. I have learned the hard way that many of my students in this unit don't have much of a statistical background, and frankly, it's not really necessary for this part of the unit. So I'm going to pass over that bit, other than to say, you obviously are not just going to add up all these things like raw, right? You would need to put them on the same metric, on the same scale, to make adding them up meaningful. Yeah, maybe you can divide all the numbers by the maximum possible score. That's one way to start. Yeah? Okay. Now moving on, class, let's finish up with multiple regression. So here's an overall summary. Yeah, I mentioned some of these things already, so I'm just going to focus on a few key points. The first is that multiple regression really is the most effective of all of these decision rules for maximizing validity. It exploits all of the information that you get from your valid and reliable selection tools and from your criterion, and so it is the best decision rule for maximizing your criterion. Full stop. It is the most effective. It's also very flexible. It can handle lots of kinds of data. The trouble and the reason a multiple regression is not used very often is that it requires that you have data on at least 100 employees who have had this job at your company before. And this simply is not always possible, especially for highly specialized jobs. Yeah, even 75 job incumbents will not cut it, class. 100 is the bare minimum for getting stable and trustworthy weights. Yeah, in fact, actually, the number is closer to 150 because you still need to split your data set into a training sample and the test sample to cross-validate and minimize overfitting. Yeah, so this approach is fantastic, but only when compensatory decision rules are appropriate. Yeah, and when you're working in a big company with a lot of hires and job incumbents that you can use for data mining, quote unquote, in this case, to work out the best possible weights. Yeah, in the absence of that, you're gonna have to use some other option. Now, class, once you have your scores based on the compensatory approach, you can use top-down selection to rank the employees. So basically, you create a score, a total score for all the employees. Yeah, you then rank them from highest to lowest, and then we select the person who scored the highest, and then the person who scored below them, and the person who scored below them, and these are the people to whom we make offers. Yeah, this is top-down selection. We start from the top, and then we go down. Yeah. Now, this approach is great for maximizing job performance. It's highly valid, but it's also vulnerable to adverse impact, which, if you'll remember from the previous lectures class, is bias to underrepresented groups and the protected groups. Yeah. Risk of demographic unfairness, among other things. Yeah. Now, like I said in my lecture on cognitive ability testing class, there is no such thing as a purely unbiased algorithm. Yeah, they're all biased in some way. Even the algorithms that we use coming from the multiple regression model will have some bias in it. Yeah, so this will need to be accommodated in some way. Yeah, it'll be accommodated partly by using selection tools that have minimal risk for adverse impact. It can be accommodated using, well, actually we'll get to that towards the end. Yeah, there are approaches we can use to compensate partly. Now, let's move on now to non-compensatory strategies. These are our decision rules that are based on minimizing deal breakers. So, the multiple cutoff approach class has you choose candidates who score above your acceptable minimum on all of your predictors. Yeah, so you work on what is the minimum that what is the minimum that an employee must be on all your KSAOs, and set the scores accordingly. Yeah. On the other hand, the multiple hurdle approach, what it does is it is the same thing, but it's one step at a time. You weed out candidates slowly as they progress through selection. So some candidates are weeded out in the application form process, then some of them proceed further, then they get weeded out during the first interview, the second interview, the third interview, assessment center. If you've been through a process like that with multiple interviews and so on, then you have gone through a multiple hurdle selection process. Yeah. And both of these techniques can be combined with multiple regression to help you rely on the data to work out what the cutoff or what the hurdle should be. Cutoffs assume that the job requires a bare minimum competency on all predictors. Yeah? If you are too weak on one predictor, the other predictors simply cannot compensate. That's the baseline assumption for multiple cutoffs. Yeah? So, for example, you might set a cutoff for physical fitness among police officers because it is too risky to have an officer who is grossly unfit. Yeah, if you have an unfit police officer, they will not be able to do some critical parts of their job, and like having good interpersonal skills will not compensate for a lack of fitness. Yeah, in the case of police officers. So for that sort of job, you will want to use cutoffs or hurdles. Yeah. Now this approach has some key advantages. You end up with a job candidates who are minimally qualified. Yeah, they meet the bare minimum. But that is also the disadvantage, which is they are, tend to be the bare minimum. Yeah, rather than necessarily the best. One other advantage is this approach is very easy to explain to managers. Yeah, so it's easy to get manager buy-in for multiple cutoffs. However, on the other hand, it is fairly hard to work out what the right cutoff value is. So what is a fair cutoff for every selection tool? It also involves assessing applicants on all the predictors, which can be fairly expensive. Yeah, so that lowers the utility of the whole selection process. So really, the ideal use case here is where there are some attributes that are absolutely essential for performance, and that should be present in employees from day one, and that there's a minimum level necessary to perform the job safely. Yeah. Class, here's some guidelines on selecting cutoffs. I'm going to focus on the key points here. You want to let job analysis drive the process, and you want to involve people who are currently or who previously have held the job in the process of identifying cutoffs. Now, let's get to the multiple hurdle process. So with multiple hurdles, we might start with 500 candidates at the application process, do the first interview with 200, then put 100 through testing. 50 of these will complete a work simulation, 20 of these will be selected for final interview, and finally 10 will be given an offer. Yeah. Now, the multiple hurdle approach requires job candidates to pass a series of selection tools in a very specific sequence. It's the application, then the job knowledge test, then interview, then references, for example. Now, the sequence class depends on a combination of factors. It depends on the cost, the utility, and the importance of the predictors. Naturally, you're going to want cheaper predictors first, but also things like references that are not particularly expensive but can be time-consuming for the referees. You may want to do those last. Yeah, so you're not wasting referees' time if you have no plan of hiring that job candidate. And of course, what you're going to want is critical predictors being selected first. Yeah, so if you're selecting critical predictors first, you don't waste the candidate's time and your own time if they can't even pass the most important hurdle to begin with. So, class, again, this approach is non-compensatory, and the mindset here is we are trying to avoid deal breakers. Yeah. Now, the advantage of this approach is that it's much more cost-effective, and it leaves you with minimally qualified candidates. Yeah, right? The disadvantage is that it can be challenging to work out the sequence and how high the hurdles should be every step of the way. And ironically, this can actually make it take longer to make a decision. So it's cheaper, but it takes more time. Remember, class, that you will need to schedule each of these hurdled selection techniques with job candidates, with the interviewers, with the panel, with the test administrators for tests. So you have to get a lot of scheduling done one after the other, and that ends up really stretching the time span involved for selecting job candidates. So you're trading off money for time when you're using multiple hurdles. You are saying, you know what, I'm okay for this selection process to take longer as long as it's cheaper and we get someone minimally qualified who does not possess any deal breakers. Now, hurdles are better for jobs, class, in which there's a lot of training available for new hires. And the same applies for cutoffs, actually. When certain KSAOs are absolutely critical to possess for newly hired employees. This point, class, is worth considering very carefully. You always have the point of saying that any given KSO isn't necessary for people to have the moment they're hired and can actually be developed with experience and training. And in some cases, that's okay. So part of the complexity, class, that goes into designing a selection package is working out which KSAOs are trainable versus which are necessary to select for at the outset. Lastly, class, note that we can combine hurdles with multiple regression or other compensatory approaches. Yeah? For example, in the middle of the selection process, after jumping through the first two hurdles, we can have an assessment center with multiple selection tools. Yeah? Fairly typical. Then we use regression or weighted approaches to pick the best performers on all of these selection tools. Yeah, so we integrate a weighted decision process or a regression-based decision process in the middle. And then the best 20 proceed to the final interview. This approach, class, gives you the best of both worlds. So you're no longer settling for someone minimally acceptable. You are also choosing the best performer on these key techniques. Yeah. So combination of approaches are also an option that's available for you. Yeah, it lets you combine the benefits of both kinds of approaches, but it tends to be a fairly like boutique and tailored thing specific to the job at hand. Yeah. Now, in all of the decision rules that I've covered so far, when we get to the end, we rank the job candidates from highest to lowest, and we pick the highest, yeah? Like I said before, we call that ranking scheme top-down selection. And top-down selection can be applied to all of the decision rules that I've covered so far. Yeah, it can be applied to weighted, unweighted, to hurdles, to cutoffs. And it's great for validity, but it creates a risk of adverse impact. So the alternative is to use banding. With banding, we set a range of scores or a band, and we say that all scores within a given range, we treat these scores as equal to each other. Then we pick among the equal candidates based on other attributes like diversity characteristics. This approach recognizes that our measurement does not have perfect reliability. Yeah, our measurement has noise. There's measurement error. And so the differences between job candidates, especially at the top of the range, could just be due to noise or measurement error. Yeah. And so we can then say that all candidates within a given band, we say they are basically equal, and any differences between them are due to noise. So within the top band, let's pick a diverse mix of candidates, yeah, covering the range of diversity that we would want in the organization. So here's what a set of bands would look like. Every bracket corresponds to a band. So someone with a score of 81 is treated as equal to someone with a score of 78. We say that the differences between these two numbers may just be noise, measurement error. Yeah. Banding gives employees more flexibility in making hiring decisions and can enable you to select diverse candidates. You might say that, you know what we're going to do? We're going to select an even mix of genders, races, and sexual orientations among people in the top band or the top two bands. Yeah? And we might want to do this, class, because there are social and financial benefits to having a diverse workforce that, go beyond just predicting job performance. But there are downsides. It can still come across as potentially discriminatory. The legal status of banding is still unclear. So if you decide to use banding but don't actually reduce adverse impact, you will actually not select the best candidate and could end up hurting the business. So banding does not have great validity. It actually has just okay validity. Definitely not as good as top-down selection, but it can end up being beneficial ultimately because it lets you select not just based on future performance, but also based on diversity. Yeah. So ultimately, class, when we're choosing selection procedures, these are the considerations we want to work out. Should the procedure be sequential or not? Yeah. Should the decision be compensatory or not? Should the decision be made based on ranking? Yeah, on top-down selection or based on banding? Mm. And there are also administrative considerations. We will want to work out how many applicants do we expect? And what is the cost of the selection tools that you're going to use? So basically, what are the costs involved in terms of money and time? And here, class, in this final slide, we have an overall summary of key considerations. And remember this final bit, class, that every selection process will have room for improvement. So constant auditing and evaluation is needed for continuous improvement. And that's all I've got for you, class, on selection decision making. And this ends our 6-part lecture series on selection. After this class, we will move on to recruitment and then retention as we finish up the unit.